Okay, YouTube, in my last video in my module on dependent independent probabilities, in which we're going to further explore conditional probabilities and talk about how we can compare them. So I think the best way to do this is just kind of dive into this problem here and talk about what it is that we're finding, and then kind of look at anything that shows up pattern-wise. So we say a jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. It says before each workout, though, he randomly selects a route and then determines the number of calories that he wants to burn, whether he reaches his goal or not. So what we see here is this table where we can see it's not necessarily a two-way table. We have kind of 3 rows here, but we'd say 3 routes, and we could see that after he sets his goal and does this in terms of calories, he either reaches his goal or reached his goal or didn't reach his goal. And so with this table here, what we could do is we can construct our relative frequencies to help us determine which route he should use if he wants to reach his goal. And so when we look at this, we say, well, step 1, what would we do first? We'd say, use these findings to make a two-way table that shows the joint and marginal relative frequencies. There are a total of 50 observations in the table. So I'm going to leave myself a lot of room here, as a matter of fact. I'm going to put a lot of room this time. So we'll get our table rocking here. And I suppose that I need to extend this even further. I'm so used to two-way tables. This one had 3 routes. And so, let's try that again. We could say route A, B, C, and total. Okay, and then up here we have reach goal, and not reach goal, not. Okay, so what I'd like to do is basically convert all of these tally marks into actual numbers here. We know that there were 50 total observations. And so when we look at this here, it looks like we have 5, 10, 11. Okay, so I'm going to write 11 here. I'm going to write here 6. And so that would be a grand total of 17 in that category. You notice I'm putting it in the corner here because we're going to have to make some calculations here. But we'd say of our route B, reaching and not reaching our goal, it looks like we had 11 here as well, reaching the goal. But we only had 4 in which we did not reach the goal on route B, or he did not reach the goal. So 15 total there. For route C totals, we would say that we had 12 times on route C in which he reached his total, but 6 times in which he did not. So that's a grand total of 18 total trips on route C. So in terms of our totals here, how many total times did he reach his goal? Looks like this would be 33 plus 1 is 34. And then over here we would say how many times he did not. 6 plus 4 is 10 plus 6. We would say 16 here. So our grand total 34 plus 16 would be this 50 you see down here. And of course all of these would have to add up to 50 as well. And so what we're going to do is we're going to calculate the relative frequencies first, the joint and marginal relative frequencies. And of course we simply always do this by taking these values here and dividing by the total number that's in the table in the first place. So essentially, we're just going to divide everything here by 50. So I'm going to take a moment to fill these in. 50th, 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 50, 50. Okay. So anyways, let's go ahead and work on getting our percentages here. So when we say 11 divided by 50 here, let's go ahead and get our calculator. 11 divided by 50 is going to be 0.22 here. So we say 0.22. How about we do our 6 divided by 50? We say 6 divided by 50. We get 0.12. So we say 0.12. And if we were to add those together, that should give us what we get right here, the 17/50th. But it seems to me that this should be 0.34. So now looking down here, we say 11/50th. Well, that's the same as what I saw just above this. 4/50th. Now 4/50th, get my calculator back out here. 4 divided by 50 would give us 0.08 as the joint relative frequency here. So we would say 22% plus 8%, that'd be 30%. So we would say this is, oops, I almost wrote 30%. I meant 0.30. And then, working downward here, we'd say, okay, so 12/50th bigger than, 11/50th. We say 12 divided by 50 would be 0.24. So we say 0.24. 6 divided by 50, I recognize that from up here. We'd say that was 0.12. Adding these together, we get 0.36. So 0.36. So now the neat thing about this is we could just add vertically to find these likelihoods down here. And that's simply what I'm going to do. We'd say, okay, well, we get 20, 20, 20 is 60. 2 plus 2 plus 4, that'd be 8. So we get 68%, reached of the times he reaches his goal. But the other percentage of the time, 16/50th of the time, we say that'd have to be 0.32, which is the sum, of course, of all of these. He did not reach his goal. So for part 2 of this video, which can be kind of seemingly confusing, we're trying to decide which route this person should use. And so when we're talking about this, basically what we want to consider is, okay, well, if we're trying to reach our goal, essentially, and we want to know what route to use here, what we're going to do is we're going to take each relative frequency in this reaches goal column here, and we're going to divide it by, okay, dividing each relative frequency in the reaches goal column by the marginal relative frequency in its corresponding row. So essentially, we're going to say, okay, well, of all the times we ran route A, basically, that'd be 34% of the overall time. How many times do we reach our goal? Okay, so basically, what's the probability that we get our goal given that we're running route A? And so rewriting this, of course, we say probability of A and goal, okay? And we would say over the probability of just A. And essentially, when we write this out here, we're saying, well, the probability of A and goal would, 22% of the overall time was route A and reaching the goal. But we say of all the times that he ran route A, we would say 22% of the time divided by 0.34% of the time. That's not bad. So we're going to take a look at what this value would be here. We'd say 0.22 divided by 0.34. Looks like we get about a 0.6471-ish. So approximately 0.6471 or 64.71% of the time. Okay, so now looking at this, we say, what's the probability that he reached his goal given that he ran route B? So this would be the probability of B and goal all over the probability of B. Rewriting these here, we would say, well, the probability of the time that he ran route B was 30% of the time. Now, what's the probability that it was on B and he reached his goal? So of the times that he ran B, this is the percentage of the time that he was successful and reached his goal. So we say 0.22 divided by the total number of times running route B. This should represent the total overall percentage of route B runs that he reached his goal on. So we would say taking that 0.22 and dividing by 0.30, we get about 73.33% of the time. I'm going to skip straight to a percentage on this guy here. So far, route B is probably the best possible chance. Now let's look at route C. So what's the likelihood that according to the data, he reached his goal given that he was running route C? So we say probability that we're reaching our goal given that we're running route C. And so again, let's go ahead and rewrite this first. We say it's the probability of C and the goal over the probability of C, So we say probability of C and goal. We would say route C and goal 24% of the time. Now, of all the times he ran route C, which is 0.36% of the time, what percentage of the time did he reach his goal is what we're trying to decide here. And so we would say 0.24 divided by 0.36, and we get about 66.67% of the time. So what we can determine here, comparing these conditional probabilities, is essentially that, of the times, how likely it is that he's going to reach his goal given that he runs a certain route. We would say that it is most likely that he's going to reach his goal given that he runs route B here. Cheers.